Welcome to October Cybersecurity Awareness Month, and we are running. I love these starbursts. I don't know how that happens, but thanks for the excitement and energy around October Cybersecurity Awareness Month, and we are kicking off OWASP October. And what better way to kick it off than with the Corey Ball? Corey, thanks for joining me to kick this off.
Of course. Thanks for having me.
Oh, always, man. The godfather of hacking APIs, if you will. Yeah, everyone, let us know where you're joining us from. It's always fun to see all that activity in the chat. And we are running this thing, we're calling it OWASP October. The idea is we want to dedicate one of these sessions to each of the OWASP top 10. It's actually going to take a little more than October to get through it all. We're doing 2 sessions a week, generally every Tuesday and Thursday at this time. Today, we're kicking off with OWASP number 1, broken object level authorization. Probably the most important, certainly one of the most important of the top 10 that we talk an awful lot about, and certainly in our breach sessions comes up quite a lot. So let's dive right in. We're going to try to keep these fairly efficient, and as always, we value your input. We'll do our best to keep an eye on the chat here as well. But the way we're going to structure this is we're going to start with kind of what is BOLA, right? And we're going to talk about just like the theory and where you can learn about it. We're going to share some real world examples. Corey's going to give us a live demo, a live example of BOLA. So I'm real excited to see that. I haven't seen that before. And then we're going to talk about what can you do as organizations to protect yourself from BOLA, from broken object level authorization. All right. So Corey, you really don't need much of an introduction. You're the co-founder of AppSec University, the author of Hacking APIs. You got a brand new course coming out later this month on MCP security, the authority in my book on all things API security related. And as the CEO of Happy Labs and all those years of experience hacking APIs, let me just start with a question for you. Of all the things, when you're in pen tests, where does this issue rank on the things that you see in the wild?
Yeah, it's definitely at the top. There's a handful of reasons that contribute to that, but essentially when we're looking for the sensitive exposures that are going to lead to critical findings, typically it's going to be BOLA. And part of the combination of reasons is that they often deal with the requests involved, often deal with the most sensitive information that organizations are trying to protect. In addition, a BOLA request and a BOLA attack by an adversary in the logs looks a lot like, if not completely identical, to the API being used as it was designed. And so a request is being made for resources that belong to a certain user, and the technology in between the deployment and testing and everything else, everything sees a valid request being made, and it's hard for automated tools to be able to detect the logic that user A should only have access to be able to create, read, update, delete resources from user A and not user B, C, or D. And so we're typically looking for the requests that create the resources and then interacting with those resources and then manipulating those to test to see if we're able to attack those from another account, a user B account or something else.
It is really true, right? When we analyze literally hundreds of breach examples out there, OWASP number 1 is right there at the top, right? And in some ways, I don't know, Corey, it feels like it doesn't even require an extreme level of sophistication, right? As Katie Paxton Fear likes to say, like all she does is change zeros to ones, or user IDs, the increment up or +1, -1. Is that true?
Yeah, that's definitely true. I would say from when I started writing hacking APIs through now that there's been some maturity, at least in the APIs that I've been testing. And so in the earlier, up to like maybe 2022 or 23, you'd see a lot more incremental IDs being used and then having the authorization controls missing there so that they were vulnerable to attack. Yeah. Now, as we'll see in the demo that I'll do later, a lot of teams have switched over to using UUIDs all around and having more complicated either tokens or resource IDs. So then now the new challenge is, okay, we can't brute force those as easily. UIDs you can't really brute force at all, but you can find requests that handle resources, and then you can see if you can manipulate those in other places. And the funny thing is, the UUID being a complex ID may even give some developers additional confidence that this is secure because it's so complicated to begin with.
And it seems like, as I was preparing for today, there's making the IDs like unguessable or difficult or non-incremental is one thing, right? But if that ID somehow leaks or becomes known, right, you're back in the same problem you had, right? So then it's about having those guardrails. So let's step back and look at what is BOLA, right? And so here I've literally just Googled OWASP API security top 10. It landed me on the OWASP.org website. And I navigated to OWASP number 1. And to be clear, we're talking about the API security top 10, right? There are quite a few different top 10s, but we're looking at the API specific one here, right? So let's just kind of step through this here, right? So threat agents, security weakness, impact, okay? So let's just start on the left here. The threat agents, exploitability, easy. Right, so attackers can exploit API endpoints that are vulnerable to BOLA by manipulating the ID of an object. I like to dumb things down so I can understand it. I think about, can user A access user B's data? Excuse me. So like, all right, and we'll give an example of this here, quite a few examples of this, right? So typically users have user IDs, right? It could be I'm 001, Corey is 002, or some more complex looking thing. But at the end of the day, I think the core of this is there's an object identifier. And this object identifier could represent a user or a file or a transaction. And I don't know, Corey, like flesh that out a little bit. Like what is the root of BOLA?
Yeah, so for an API to interact with resources, it needs to know who's requesting this, are they authorized or not, which that's part of where this could break down. Plenty of APIs that are out there are just saying, yes, this is an authenticated user to our site. It's not saying, yes, this is Dan, and Dan should only be able to access Dan's resources. And so it needs to know that part of who's making the request, and then it needs to know what resource is being interacted with. And so this could be anything from a user's profile, a user's vehicle, the books that are checked out by a user, anything that's a resource on the server side that the user is attached to and has permissions to be able to interact with. And so they leverage IDs in a variety of forms. This could be, if we're going with the book example, it could be the library itself has an ID, and that could just be the name of the library. So that's the ID for the library object. And then which book are you checking out? And books, instead of having those all laid out by titles, those will have a unique identifier to be able to easily identify and request the book that's involved there.
So what I found interesting here, so security weakness, let's go to the middle, right? Detectability. So prevalence widespread, that's for sure. Detectability easy. And I have to take like issue with that, right? If it was so easy to detect, you would think it would be easy to block, right? So maybe I'm misunderstanding. Like, what do you think they're saying here about easy detectability? Am I misunderstanding this?
On the testability side, maybe easy, because from a developer standpoint, you'll have all the information that you would need. So you'll have user A's resource ID and the objects that only they should access. So you could easily detect it from that perspective of, can I build a test that says user B cannot access user A's resources? With perfect knowledge and building out a test, sure, you can detect it at that standpoint. But from a tooling and vendor standpoint, very challenging, because the workflow involved is going to have all the knowledge. It has to create the resources and then later interact with the resources from that user.
Yeah, so I get your point, right? So maybe this should be discoverability, right? If you want to find BOLA in your app, it's actually not that hard to simulate. Create a test sequence that logs in as Dan and then attempts to access Corey's records, right? And of course, multiply that by the n number of permutations of users and object types and actions. And so it can multiply it a whole lot. But if at the end of that, you get a 200 and a bunch of data coming back, you got BOLA. Is that what you're saying, Corey?
Yeah, I think that's accurate. Yeah.
Yeah, and so then, but what's hard is to detect it as it's happening out there in the wild. And I think this is really important because all these breaches that we see of BOLA, I mean, you got to believe 99% of them have firewalls in place and other detection logic and things like that. So I think, to me, what I take from that is BOLA exploits, like as you said, if you looked at the logs, the request looks totally valid. I see a GET request for some object gobbledygook ID, right? And that's it, right? Does the WAF know that object belongs to Corey or to Dan or to somebody else? It's a level of context that really just doesn't exist at that network layer. And I think this is what makes BOLA so especially challenging. It's probably why it's number one, why it's so widely exploited is, if you think about it, the exploit is in the authorization logic. What should Dan be able to do? What should Corey be able to do? And that is a layer higher or lower, however you want to look at it, than what a WAF can understand. And it takes the knowledge of the internal logic of your application. And we can't train our firewalls to know every app and everything that should or shouldn't be done. Corey?
Yeah, if the WAFs are looking for unique characters, special characters, or too many requests or anything like that, really an attacker could go in with surgical precision and create a resource, see how the ID is handled, see how it's handled in other parts of the app, and simply make a valid request. And so there's not a lot of brute forcing that's necessary. There can be if the resource IDs are predictable and incremental, but in the instances where the app itself reveals those IDs in other places, an attacker can be very careful in the quantity of requests, and things like behavior and might even go out the window because they're just making a series of valid requests that don't even trigger anything.
And we know there's a whole class of API security runtime tools that, try to do a better job, be API intelligent and things like that. But I think the fundamental laws of nature still apply. And so let's pivot into some examples here. So I was just talking to you, Corey. I call this the grandfather of BOLA. Probably the first or one of the first examples. I'm sure there are older ones. But do you want to describe to us what happened here? We actually even referenced it in your book.
Yeah, so this is back in 2018 to 2019. The US Postal Service was just releasing their new improved visibility API. And I think part of why it was attention grabbing, one, the 60 million users data, that's pretty huge. But two, it was the first large case that had a public assessment done just before. So the Postmaster General scrutinized the API before it was released. And a problem that continues to this day is it appears that they didn't use tools that were geared at testing APIs specifically. And they used automated web app and vulnerability scanners that have been around for a while. The scans came back with a few issues, but none that were as devastating as the BOLA that affected 60 million users.
Yeah, and I remember you telling me about this, right? There was the Office of Inspector General issued their report. They had fixed the minor issues and it got a clean bill of health. And 2 months later, 60 million records exposed. And as I understand it, this informed visibility was for bulk mailers to check on the status of their deliveries. And there's an API to check on the status. Not only could you check on the status of your deliveries, you could check on the status of anybody's deliveries.
Yeah, and I'm pretty sure the resource ID was just like the address. And so even if you were in an apartment building, your one address could reveal everyone else in the apartment building.
Yeah, exactly. So classic BOLA, right? Let's keep going. Alex, I want to get through a few more examples and then I want to see Corey's demo. This is a new one. I've talked a lot about this. This is McHire, Ian Carroll and Sam Curry. They basically poked around on McHire.com. There's a chat bot. It helps you create your job application. behind the scenes. Somehow they found that this chatbot was querying an API. It was associating a lead ID with them. First of all, like, how would one discover that? Is that just by watching the traffic?
Yeah, so if you're on McHire and you use DevTools or a proxy, then you should be able to see all of the requests that are taking place in between the client and the server, being your browser and the web server. And you can go through, they could filter specifically by XHR requests and see the data that's involved with those.
Is XHR like a certain like thing? Is that a standard kind of object or format?
Yeah, it's a standard request format.
All right, that's news to me. All right, and then of course, you know where this is going. They then got rid of the UI. I don't know what this, I guess this is just their terminal that they're showing us here, but they don't look for their ID. They look for someone else's ID. And boom, there you go. We got all of that person's information. So that's McDonald's. Then we got Bumble here. I use this as an example of OWASP 5 broken function, but this is also OWASP 1 BOLA, because not only it's a dating site, and apparently there are some options you can govern, like how much data you share about yourself. Like maybe I just want people to know I'm in San Francisco, or maybe I want them to know their physical distance from me, right? But here, by hitting the API directly, it bypass those privacy settings. And so it would just reveal all of the details about that user, including distance. And apparently basic math, right? If you were to create 3 different accounts, you could triangulate and not only find how far you are from someone, but actually their exact location, right? That's probably excess data exposure, but this is still BOLA, Corey, because I could actually access data on other users and see info that I probably shouldn't be allowed to see.
Yeah, it's definitely a combination. And that's the big difference between real world findings and a structured top 10 list. Is in the real world findings, it's always going to be a combination of vulnerabilities, and it could definitely be a Venn diagram of which categories it falls into.
And I see some good questions. Roger will definitely touch on that. From Tony, where does BOLA rank on, in your experience, Corey, as a not bug bounty, but a pen tester, right? Is it as common as we think it is?
Yeah, it's common. We often find it in one way or another across the APIs that we test. And it's mostly about demonstrating impact, and that's what drives the criticality. And so if I can use a BOLA weakness to find public information about a user, that's not going to be as serious as healthcare records or payment records or anything else.
Yeah, and let's just look, I think this may be my last example here. So this is, I touched on this last week on our breaches webinar. Here, there's an example where they were able to discover all the robots in that this vendor supports. You could actually look at, these robots are like waiters and hospital room cleaning robots and things like that. You could pretty much go in and see the entire inventory. You could look up by store ID. You could change the names. You could look up what robots are running in this physical location and all of their details. But you could also send commands to tell them what to do. So that's definitely not BOLA. That's probably 5 broken functions, but it is BOLA, right? Being able to view all of this robot activity, where they are, what are they doing. That's certainly not information that you want out there in the wild. That should be really governed to the owner of that particular account or that tenant.
Yeah, you don't want anyone being able to make your robot go rogue and start Terminator.
Yeah, no, think about it, like you could tell it to stop cleaning emergency rooms and things like that. But I do see some good questions. Is this different from broken access control from Deshant? What do you think, Corey?
So BOLA is a form of broken access control. Yeah, so broken access control would be the larger category that this would fit under.
And I see, like, from Pedro, from Roger, we're definitely going to talk to you about testing here in a minute, but let's pivot here at this point, Corey. And are you prepared to share your screen?
Sure, yeah. And just to give a little information before the demo, so I'm going to be using one request, which is a CTF we designed and ran earlier this year, mostly to demonstrate the tactics that would be used, what we're looking for as we're testing, and what would lead to a BOLA finding. And One request makes for a good example of that because it doesn't have incremental IDs. With the standard format of a UUID, it would take a standard computer requesting every millisecond for quadrillions of years. And to be able to brute force a UUID is unlikely. We'll see what happens once quantum comes out, but for now, not a feasible attack method. And so instead, what you need to do is determine how an application is handling resource IDs and then requests for authorized findings. So how is a user supposed to interact with their own resources on this site? I'll share my screen to show off one request. AppySec University actually hosts a version of one request. So you can go to one-request.appysecuniversity.com if you want to follow along. And yeah, if someone could drop that in chat, that would be
good. We'll get that in there.
And yeah, let me see here. I'll share my screen.
All right, let me bring that up.
Cool. So this is the one request landing page. Essentially, one request to rule them all is a style of CTF where if you've handled APIs before, you'll have the experience of needing all the right parameters to be able to make one request. So to win this competition, all you have to do is make one request, but you have to build it up by searching through the app for all of the right parameters to fill into that one request. And this is also unique because it's not based in a browser. It's not based in the graphical user interface. Instead, we want to access the API. And here we can download the Open API spec or a Postman collection up above here. And so I've downloaded the API spec. This is what you'd see. You can take this and bring it over into Postman. In Postman, you would import that spec in at this location. I've already done that, and I've done it again. So here is the one request API. And let me get rid of this one. With the one request API, the first thing is you can go through and see what requests are involved, but quickly you'll find out that you need to be an authorized user. So the first thing you need to do is register for an account. And here I've set up a username, a valid email for the username, and then a password. And once you've submitted that request, you'll get back your user data object. And so here we see the name, the role, and the ID. And so right away, this tells us, okay, as a tester, this is not going to be one of those incremental ID situations. We have UUIDs that are representing the user. Postman is great for being able to see the breadth of an API. So all of the requests that are being made across the app, and that works really well for specific types of testing. If you could bring up my screen, I can share that again. So in Burp Suite, you're going to see the individual requests, and it's great for being able to dive deep into testing a single request. Postman is great for being able to test across the entire collection of API requests. And so if you think of something, let's go up here, not to get too sidetracked, but if we go here, we can see there's a V2. And so anytime there's versioning, which maybe this is spoilers for Thursday's improper inventory management, but anytime there's versioning in place, in Burp Suite, you're going to be able to test those easily per individual requests. But in Postman, I can test across the entire API pretty easily by turning this into a variable that I could then replace with anything I want. So if I wanted to test every single request for V1 internal private UAT, then I could make that into a variable and request it that way. So back over to...
You were showing us, like, we have a complicated ID, can't brute force it.
Can't brute force it. And so what you'd want to do from an application standpoint, I will go through and use the application as it was designed. And so one request to rule them all is a Middle-earth-based activity planning application. And so in that, we can see an activities endpoint, and it includes the abilities to create new activities, to fetch public activities, so on and so forth. And so if I wanted to, first thing you're going to have to do is make a valid token. And so you do that with retrieve and access token through this token request. You need to supply your registered username, which is the email, and then add your password, and then you can create this token here. And we will add this token to our variables so that every request has the correct token. So here you can see under authorization, we've added that token. And so we will update it here. You can easily script this action as well. And then if you need help doing that, Postman has the PostBot, which is an AI tool that should be able to help you through that. So you have your token, and then you need to start interacting with the application. And this request is to look at all of the locations where activities are taking place. And this is under an items data object, but right away we can start to see more UUIDs in use. We even see user IDs that are associated with certain activities. So even though this is meant to be a public fetching all locations of these events, you can see the event ID, but you can also see user IDs that are associated with that. And so right away, this would trigger a test to see which requests involve user IDs that I could potentially use this to see if I can interact with their resources elsewhere. You can see that there's a whole group section, and in that group section, there's a user ID endpoint, and there's the ability to add members to a group, delete members from a group, or get members. And so in here, we can see, is this a user ID that we'd be able to replace? This is actually a group ID, so this shouldn't work. But we want to find the places where user IDs are involved. And so in this fetch all users endpoint, this is trying to get all users, but maybe we could specify a specific user. And this is just one of the ways to be able to test for it. So this is an invalid request. We can also fetch all activities. So not just the locations, but we can also see what public activities are taking place. Maybe it's something we want to join in Middle Earth, and we can go through and leverage these IDs elsewhere as well. And so with a complicated app like this, you need to start taking notes and organizing these different IDs as you're collecting them, because there's a variety of UIDs being used all over the place. And it's easily to use the wrong one in the wrong place. So you need to check. And here, at least by the format of what we were looking at, and I'll just put it up here for a second. Starting with the CDD looks more like the creator IDs than it does for the other IDs that are used. And so this request here includes both a group ID and a user ID. And so if we test this, first you want to do it with a valid request being your own resources. So we can go back and see our own user ID. And then we can see a group ID down here. So we'll use both of those in this request. First, we're going to have the user ID. And back over here, we're already a part of this group, so we can see if there's another group that we can join. Let's go back to fetch all groups. Oh, I don't think we're allowed to. Let's see. Yeah. We'll create a group then. And so someone else has already created this, so we'll create a very complicated group. And that'll give us this group ID here. And we will add ourselves to the test group. And we're already a part of this group. So now what we'd want to do is search through the application for other ways to find group IDs. And then an authorization check would be something we can assume. In this case, should I have the ability in a social media type app to be able to add myself to any other group? Probably not. And so here's my group. Let's see if I can find another. Maybe back in the locations.
You made this app.
Yeah, that's right.
It's fascinating to see like the thought process and the iteration and just like the creative process of hacking.
Yep, and especially in here, like I said, with the note taking, there's plenty of UUIDs to easily test through.
So like your general process here, Corey, is you're poking around this app, you're finding these IDs, and you're just trying different IDs in different places to see what works.
Yeah, so typically I would go and I would create another user. And then this is just going to be the easiest way. So I can register for another user account and then see if I can interact with that first group from that account.
And I think you may have answered Tony's question, right? Corey, do you tend to store any UUIDs found when testing to use later to look for patterns, et cetera? It sounds like you have this notepad process where you find something, you store it, you write it down, keep a track of that.
Yeah, a lot of note taking, especially in complex apps. Okay, and so we've created this evil hacker account. And so now we can go and instantly that evil happy hacker is going to have its own group ID. And so now we can test to see if we can add ourselves to someone else's group. And you do not have permission. So this is just like a valid test that an authorization control is in place for this specific item. And so just as you'd expect, you can't add a user to a group that they don't belong to without being a part of that group. And so that would be a valid authorization check. And before I get kicked again, we can call the demo there.
All right, very good. Yeah, let's do that. So tremendous. And we'll literally have just a few minutes here left. Just in terms of what are some best practices for preventing these things, what I've been gathering here is there seems to be make the IDs not obvious, make them hard to reach. It sounds like in the case of one request, was it like, could it not have been returning those UUIDs? Should that have just been like hidden behind the scenes?
Yeah, so if authorization is being done based on a signed token, then you can have a layer there where the UUID is not being revealed all over the place. In addition, the data object for locations and public activities and stuff like that, those likely don't need to share the user UUID along with that. And that could be filtered back over on the server side. A developer here could be depending on the client side to filter it out, but once we're in the APIs, that doesn't matter as much.
So it seems like, all right, one is what's the visibility of these IDs, right? So restrict it to the extent that you really can, right? There's no need to share it more than necessary. And even then, you can't assume they won't leak out or get shared or whatever it might be. And so then it's really about the guardrails, the logic that you put in, and that has to exist in the app logic as far as I can understand. Like, it's one thing for me to know Corey's UUID. It doesn't mean even if I have that, I should still not be able to access your data.
Yeah, so even if you can't find the UUID, I should not be able to just replace my UUID with another user's and have that be successful.
That's right. That's right. And so let me, just as we wrap up here, folks, let me pull up to the screen real quick. So what do we got here? Shadow APIs of the night. Look at that. Is this, did I pull up the wrong thing here, Christine? No, this is the next one that we got coming up.
Yeah, this is Thursdays, yeah.
Oh, sweet. All right. Yeah, this is what's going to be on Thursday. We had to juggle a few things here for October. So we're going to go, today is OWASP number 1. Thursday is OWASP number 9. And so we're getting creative. We're keeping you on your toes. So come join us on Thursday, and we're going to have Damilola. She's outstanding. She's going to be joining Christine to talk about that. But I wanted to do, where are my slides here? Let me bring them up real quick. I wanted to give a little shout out to our new friend Bolt, which is this tool that we've created here. And let me just try to do a little mini micro demo of Bolt here. All right. So Bolt is this tool. It's like similar to what Corey was just showing. I'm going to use it on EasyJet. I'm not picking on them. It could be any of your websites. And if you want to discover these APIs and these endpoints, that's what Bolt is. It's a Chrome extension. I'm just going to go ahead and fire this thing up. I'm going to filter it on my high confidence endpoints. And literally all I do is just start poking around. So I'm just going to look at this particular flight. I'm going to start adding elements to it. I'll hit continue. And what you see here over on the right is it's discovering all these API calls from the traffic, right? And you can come in here and see the details, the actual construction of it, the various parameters that are being used, how they're being used, where they're being used, and so forth. And from this, it will literally output an entire open API spec, which you can see here. So that is the fastest demo of all time on that. You can sign up for this. It's in beta right now. And I know, Roger, you've been asking, like, you signed up for it, give it to me. Like, when can I get my hands on it? The delay has been, I've been smashing a few bugs, adding a few features. It turns out there's a 10 megabyte limit on Chrome. So I added a little progress bar so you can know like how far along you are with it, and some other cool features that are coming out. So folks, if you're looking to do some of this kind of like recon and discovering APIs, definitely check out Bolt, right? And there is the URL for that. And so come and check it out. We want your feedback. And with that, I'll just leave this up again. Corey, thanks, man, for joining us. Super cool demo. It's always neat to see the master in action and how you guys go about doing this. Join us on Thursday for Shadow APIs of the Night. Christine, you're having too much fun with this OWASP October. I love the creativity. And that's it. I got to hop on another webinar, believe it or not. So thank you all for joining. Corey, you're the best. Appreciate it. And we'll see you all next time.
Thanks.